Hello and welcome back to Life's Biggest Questions. I'm Rebecca Felgate and I just want to remind you that nothing lasts forever. We will all die, even our sun will die eventually. From observing other stars in other solar systems, we know what the life cycle of our own sun will be, and that it's roughly halfway through its life. We are here to tell you exactly what will happen at the end. The sun is currently around 4.5 billion years old, and in around 5 billion years it's going to reach its end of life phase. Before that, in 1.1 billion years, the sun will have expanded by 10%, making its rays hotter and brighter to the Earth. In 3.5 billion years, the sun will be 40% brighter. Then, eventually, it will reach full red giant stage. The sun uses hydrogen converted into helium to burn, but when the hydrogen supply is depleted in the sun's core, the helium ash that has built up over time will become volatile and collapse under its own weight. This causes the core to get very hot and dense, with the outer layers expanding. This process from start to finish can take a few billion years, but when the sun is done being a red giant, it will begin the planetary nebula phase. The planetary nebula stage is when what is left of the sun starts to pulsate. An expanding, glowing shell of hot gas is cast off, resulting in stellar winds. While this looks and seems explosive, it actually takes tens of thousands of years. After this, only the core remains as what is known as a white dwarf star. At first, the core is over 100,000 degrees in centigrade, so very hot, but it will cool very gradually before finally becoming a black dwarf, a cold, floating rock in space. If the sun was big enough, which our sun unfortunately isn't, instead of the planetary nebula stage, it could go supernova, then form a black hole, which would be the end for our galaxy. But that isn't going to happen here. But what will happen here? How will this whole process affect planet Earth? Well, the chances are we will have killed ourselves off long before we as humans ever experience any effects of the sun's later life stages. The Earth as a planet, however, absolutely will. As the sun begins to swell in around 1.5 billion years, it will be 10% the size it is now, which if we're alive at that time, will make things a lot hotter on Earth. What is left of our polar ice caps will melt, causing huge floods to coastal areas, whereas hotter temperatures across the globe will increase droughts in landlocked areas. This extreme change in climate may well have devastating effects for life on Earth. Then, some billion years later, as the sun approaches its red giant phase, our oceans will boil and eventually evaporate, leaving no water and therefore no life left on Earth. Goodbye oceans, goodbye plants, goodbye trees, goodbye cities, goodbye grass, goodbye people. What is left on Earth's surface at this point could very well catch fire until that too burns out. After the loss of the oceans, the Earth will eventually be barren. Following that, there are a couple of possible outcomes for Earth during the sun's red giant phase. We know that the sun will swell so large that it will definitely consume Mercury and Venus, but we're still unsure as to whether Earth will be sucked in too. If our Earth were to be sucked into the sun's atmosphere, it will collide with particles of gas, our orbit would decay, and we would spiral inward. If the Earth manages to escape the danger zone, it would still be greatly scorched, but intact. The Earth would either stay in our sun's orbit as it cooled to a white dwarf, or it would potentially escape the sun's orbit if it were to be attracted by another nearby star's orbit. In either scenario, it's hard to say what will happen to the Earth. It will probably remain intact until something smashes into it. Cheery! Either way, after a dramatic few billion years, eventually our little corner of the universe will be dark and quiet. Although, looking on the bright side, as we know, energy and matter are never lost. The material cast off in the planetary nebula phase of the sun's demise will be scattered in space and may even make up some of the future generation of stars. So as we have heard over the past few minutes, our title is a little bit off. The sun won't explode per se, not quickly anyway. The sun will expand and contract over billions of years, leading to a great, bright theatrical event in space. This happens each time a star dies. While we will probably not be around to see it, our Earth will have a front row seat to large parts of our sun's final act. When it does happen, it will be the end to a great 10 or so billion years on the Milky Way. Thank you, sun. Thanks for everything. It's better to have lived and lost than never to have lived at all. So now you know what will happen when our sun meets its end. Do you think that humans will have died out by then? Or do you think that we will be living on another planet watching from afar? Let me know in the comments section below.
What if the sun exploded tomorrow? Well, the good news is that it most likely won't. Not only just tomorrow, but ever. This isn't just because it simply just isn't time, but because the sun probably won't ever explode. When a star explodes, the event is referred to as a supernova. Supernovas can only occur with stars that are of a certain mass, and our sun doesn't quite make the cut. It's kind of weird to think that the center of our solar system, the big star that we orbit around and that keeps us warm, is considered not that big in terms of the stars out there. But again, we can always ask ourselves, what if? Which is exactly what we are here to do today. I guess if the sun exploded tomorrow, things probably wouldn't look too great here on Earth. If we had a heads up that the sun was going to explode, things probably would be a bit better, and we could ensure that some preparations were made so that maybe life could continue on. But tomorrow was a bit of short notice, and things might not exactly go great because of that. For the sake of this video, for a second we'll pretend that the sun will explode and that it could tomorrow. The sun is 149.93 million kilometers away from us and about 1,391,000 kilometers across. Light from the sun travels, well, at the speed of light, so at a speed of 300,000 kilometers per second. This means that it takes about 8 minutes for the light from the sun to reach the Earth, so anything weird going on with the sun is going to happen 8 minutes before we even realize. It is said that if the sun were to somehow explode, it would take about 134 days for the shockwaves to reach the Earth. For us to be totally out of harm's way in terms of an exploding sun, we would have to be somewhere from 50 to 100 light years away from this whole supernova event, and that clearly isn't the case, so things wouldn't be looking great for Earth at this point. The good news is that if the sun exploded, the shockwaves wouldn't be enough to immediately destroy the whole Earth, but whatever side was facing the sun at that point in time would be toast for sure. You might be sitting there thinking, wow, that sucks for one side of the Earth, but at least we have the other side, right? Well, if we had no time to prepare for this sun explosion, chances are the rest of the world wouldn't be doing too hot either. Well, they'd actually be too hot, and that's the problem. The side of the Earth that didn't boil away would now be experiencing a rise in temperature that is 15 times hotter than the sun's current surface temperature. It would also be super dark on Earth for, basically forever, unless the Earth happens to find another star to orbit, but that's not exactly a thing that happens quickly. So, with the sun exploding, there wouldn't be anything keeping us in orbit anymore. Not that we would be alive, so when I say us, I guess I'm more just talking about the planet Earth. So Earth would basically now start floating off into space. If there were any living creatures at this point, there's no way they'd be able to survive until the Earth found another sun-like star to orbit. So basically what I'm saying that is if the sun exploded, there's no more life on Earth. That's pretty much for certain. Of course, if we had a heads up that the sun was going to explode, perhaps we could find a way to move civilization onto some kind of space station or move underground or something like that. But even still, life certainly wouldn't be as comfy and cozy as it is right now. Since the sun isn't going to explode, let's take a second to talk about what actually is going to happen, because the sun isn't going to be here forever. Rather than exploding, in reality our sun is going to first become a red giant. Our sun is around 4.57 billion years old right now, and it has a lifespan of around 10 billion years. The sun, like most stars in the universe, is in its main sequence stage of life. During this stage, there's a lot going on within the star. The nuclear fusion reactions in the core are fusing hydrogen into helium. During this stage for our sun, every second there are 6 million tons of matter being converted into neutrinos, solar radiation, and a ton of energy. Not a ton as in the actual measurement, I just mean a ton as in a lot. This process is great, but it cannot last forever because there's a finite amount of hydrogen in the core of the sun. As more hydrogen is converted to helium, the core of the sun shrinks and the outer layers of the sun move closer to the center and experience a stronger gravitational force. This whole process puts more pressure on the core of the sun, which in turn is resisted by the resulting increase in the rate at which the fusion is occurring. What I'm trying to say is that the longer this process takes place in the core, the faster it gets, and the brighter the sun gets because it's outputting more energy. In actuality, this means that in 1.1 billion years from now, the sun is going to be 10% brighter than it is now, and this also means that in 3.5 billion years, the sun will be 40% brighter than it is right now. That kind of an increase increase is going to cause the oceans to boil, there definitely won't be any ice caps left, and basically the Earth will be a planet similar to what Venus is like right now. In about 5.4 billion years, the sun will be coming to the end of its 10 billion year life, and that will happen when it runs out of the hydrogen fuel it's been existing on. With the hydrogen store completely exhausted, the helium ash that has been built up is going to become unstable, which will lead to it collapsing under its own weight. From here, the core of the sun is going to heat up and get more dense, which will cause the sun to grow and expand, and this is the red giant phase. In the red giant phase, the sun will expand large enough to encompass the orbit of Mercury, Venus, and possibly even Earth. At this point, if Earth survives, it definitely will be way too hot for any life to still be existing on the planet. And this is even if that whole 40% brighter thing we already talked about doesn't get all the life on Earth first. In this red giant phase, there's only about 120 million years of active life left for the star, but these years are full of activity. First, there will be a big event where about 6% of the core and 40% of the entire mass of the sun will be converted into carbon in just minutes. The sun will then shrink down and be at about 50% of its brightness. In this stage, once all of the helium in the core is burnt out, the sun will reach its next phase, which is asymptotic giant branch, and this is when the sun expands again, but way faster this time. In this phase, the sun will become quite unstable and it will go through a series of thermal pulses. The expanding sun at this point will have probably grown enough to encompass Earth, if it hadn't already, and at this point, if it still isn't big enough to do so, Earth still wouldn't be able to host any life. Or at least any life as we know it, I guess. Soon, well, not soon, but in terms of space-time and the timeline of the universe soon, the sun will be at about half of its current mass, the remaining planets in the solar system will be completely different than they are now, and this is when the planetary nebula will begin to form. Eventually, once the core of the sun is exposed, the naked core will reach its peak temperature, and this is when the core will then start to cool, and the sun will become what is called a white dwarf. The planetary nebula will disperse in about 10,000 years, but the white dwarf will be around for another couple trillion years before it fades out to black entirely. It is crazy to sit here thinking about how if our sun was only 10 times bigger, it would end in an explosion or possibly a black hole. It's difficult to comprehend how this star that is so huge to us is relatively small out there in the universe. The sun may not end its life in a big explosion, but that is definitely not to say that there isn't going to be a ton of action happening in the last stretch of its life. The good news is that we don't have to worry about the sun exploding, and hopefully we don't have to worry about it going anywhere for a long time. By the time the sun is reaching the end of its life, humans probably won't even be around anymore, so I don't think we have anything to worry about when it comes to things like this. I mean, maybe ask someone who knows a bit more about astronomy and space first though, just to double check.
Imagine, if you will, a world without conflict. Peace reigns supreme across all continents. No more fighting, no more killing. Doesn't that sound nice? Food and drink for everyone, a place to live for all. Utopian, sure, but it's nice to think about. But there's one big problem with a world like that. All of the weapons we spent so much time diligently creating would now be rendered useless. They're not multi-purpose tools, they have one purpose, and that purpose is ending lives as quickly as possible. And now they have no aim, no goal, no use. What a sad existence for these weapons. Guns and swords and bladed brass knuckles might be melted down and repurposed, but what do we do with all the explosives? I mean, our nukes could be used for energy generation, but then we end up with nationwide text alerts that make folks think that Pickering's about to become the next Chernobyl. No, instead we should do the reasonable thing and fire our nukes into the sun, right? Good call. Hello fellow friends and philosophers, and welcome back to the most mind-bending channel on YouTube, Life's Biggest Questions. I'm your voice in the void, Keegan Hughes, and today we're going to be taking a look at a potentially destructive query. What if we nuked the sun? Before we start splitting atoms here, make sure you give this video a big thumbs up and subscribe for more explosive inquisitions. Outstanding, let's begin. We're all quite familiar with the sun, at least in how we interact with it. We know it as the provider of warmth and weather and light. Without the sun, life on Earth as we know it would not be possible. It is the star at the center of our solar system. a hot sphere of plasma that could fit 109 Earths inside of it, with mass over 330,000 times larger than that of our planet. With mass over 330,000 times greater than that of our planet. How does the sun generate all this energy though? Well, around 4.6 billion years ago, a gravitational collapse of matter created our universe. Some of the matter flattened out into a disk, which now orbits around the sun. The largest quantity of matter gathered in the center and became so hot and dense that it initiated nuclear fusion in its core. Yep, that's the sun. Roughly 3/4 of its mass is hydrogen, and the last quarter is helium, with a few other elements in small quantities too. It fuses about 600 million tons of hydrogen into helium every second, converting 4 million tons of matter into energy every second. This is the sun's source of light and heat. Someday, way off in the future, the fusion in the core will run out of fuel. It'll diminish to the point where it is no longer in hydrostatic equilibrium, and the core will become much more dense. Eventually, it will transform into a red giant, and could become large enough to swallow up Mercury and Venus, while making Earth uninhabitable. Sounds like fun, doesn't it? Don't worry though, that won't happen for billions of years. But would that process be sped up if we nuked the sun? Let's consider that possibility. What is a nuke? Also known as an atom bomb, it's an explosive device that derives destructive force from nuclear reactions. Basically, they use nuclear fission or fusion to release large quantities of energy from small amounts of matter, essentially causing similar hydrogen reactions to those on the sun, but with the express purpose of destruction. One thermonuclear bomb test released energy equal to more than 1.2 million tons of TNT. Would this make a difference in the sun though? We would have to get a nuke to the sun first in order to find out. The Earth is 150 million kilometers away from the sun, a distance 387 times further than that between Earth and the moon. If we were to fly a commercial jet for around 150 million kilometers, it would take about 19 years. But that is limiting us to our own atmosphere. What if we use the fastest flying spacecraft, the Helios probes? These satellites were able to reach speeds of 253,000 kilometers per hour by using the sun's gravitational pull. If we got our nukes on a vessel like that, it would be able to hypothetically reach the sun in under a month. If everything went right and we were able to make a vessel that could carry a nuke to the sun in under a month, what would happen if we actually detonated a nuclear bomb on the sun? There's a few theories, provided that the bomb doesn't melt before making it. The most popular of these is that nothing would happen. The sun is so immeasurably huge and is constantly outputting energy that dwarfs our entire nuclear arsenal. Even if the nuke got to the sun, it would detonate and the effects would be negligible. We might notice a little blip on the surface, or maybe the explosion would alter the route of some sunspots, causing a solar flare. Otherwise, the sun could continue to work as per usual. Another idea is that nuking the sun would be a good way to signal our existence to other intelligent life in the universe. Patty Alton says that the nuke itself wouldn't have any serious effect on the sun, but if we tossed a bunch of plutonium in with it, other advanced societies might notice. Plutonium is an artificial element and would not occur naturally in the sun, so anyone picking up on this would have to deduce that somebody else put it there. This could lead to all sorts of interplanetary communication in the future. Far out. Nuking the sun leading to galactic diplomacy. We're sci-fi now. If you really want a dramatic answer, I can take it to one final, less than likely conclusion. If somehow the nuclear warhead was able to make it all the way past the corona, through the radiative zone and to the sun's core without being destroyed, it might be able to detonate and cause a new chain reaction within the sun. This new reaction could potentially alter the balance within the sun, either speeding up or slowing down its journey towards red gianthood. The likelihood of this happening is infinitesimally small though, don't cross your fingers. In the end, if somehow a nuke made its way to the sun, it would just end up being a grain of sand in the desert, a drop of water in the ocean. Sure, there would be some minuscule immeasurable difference, but the overall function of the sun would not change.
As of right now, our sun is pretty much the only star around. The closest neighboring star is 4 light years away, in Alpha Centauri. Sure, 4 light years might not seem like a lot in cosmic terms, but it definitely is a long way away. Scientists predict that 1,000,000 years in the future, 1.3 million years to be exact, another star will visit our solar system. That star is called Gliese 710, and it's only expected to visit for a short time. But what if this star decided to stay in our solar system and begin traveling toward our sun, eventually hitting it? Today, Life's Biggest Questions asks, what if our sun hit another star? Hello and welcome back to Life's Biggest Questions. I'm Charlotte Dobre. On this channel we ask the most interesting questions we can think of and try to answer them for your entertainment. There's actually a scientific term for this. It's called a stellar collision. It's defined as the coming together of two stars caused by stellar dynamics within a star cluster, or by the orbital decay of a binary star due to stellar mass loss or gravitational radiation. While it's extremely uncommon for a star to collide with another star, this type of event is estimated to occur once every 10,000 years. Scientists know it occurs because they've actually observed it happening. Back in September of 2008, scientists observed a stellar merger in Scorpius. At the time, they had no idea what they had just witnessed. It's believed that any stars in the universe can collide while fusion is still active, but also while they are dead stars, which is when fusion is no longer taking place. The star that is most likely to collide with our Sun is Gliese 710, which is 60% as massive as the Sun. Though it's estimated that Gliese won't get too close, it will hang out in the Oort cloud, which is the ring of dust, rocks, comets, and debris that circles the furthest edges of our solar system. Even so, Gliese will be 1.4 trillion miles away from us, but will shine brightly in the night sky. Very brightly. Around 3 times as brightly as Mars. Though there's no chance that it will collide with any of the larger objects in our solar system, it very well could shoot comets and debris into our solar system that have the potential to hit Earth. This actually won't be the first time that another star has entered our solar system. It happened once before, and not that long ago either, when early humans were around. 70,000 years ago, a dwarf star entered the Oort cloud, and scientists think that this type of event could have caused mass extinction events on Earth, like the asteroid that is said to have killed the dinosaurs. If a star that far away did enough damage to our planet to permanently eradicate dinosaurs from the face of the Earth, imagine what would happen if a star got close enough to hit our Sun. If our Sun collided with another star, we definitely wouldn't be around to witness it. It implies that another star would have to get close enough to our Sun that both stars would light up the sky, either doubling or significantly increasing the amount of solar energy our planet receives. That would essentially cook our planet. As the invading star got closer to our Sun, there would be an epic battle between their competing gravitational forces. They would throw mass and gas in every direction. So if there were any life forms left on Earth at this point, there definitely wouldn't be after this happens. Once the star actually collided with our Sun, it would cause a massive explosion, likely big enough to destroy most of the planets in our solar system, and send gravitational waves rippling through the universe. We know this because a gravitational wave was detected on August 25, 2017, and it was believed to have been associated with the merger of 2 neutron stars in a distant galaxy. This was the first time that an event like this was observed via gravitational radiation. The exact timeline of events of a stellar collision depend on the type of star. Normal stars like our Sun are called main sequence stars. These stars only merge in places where there are many stars in a small area of space, a globular cluster. It's believed that when stars merge in globular clusters, they actually form one star, one very hot, bright star. The subsequent star would be blue, as hot stars are blue. But let's say this is a few hundred million years in the future, and our Sun is a white dwarf. Let's say a white dwarf star collided with our white dwarf Sun. We also know what happens when white dwarf stars collide. It's called a Type 1a supernova, a massive explosion that totally destroys both stars. This would create very bright, luminous energy. Particles like the atomic nuclei of these stars could also be ejected in the explosion. The nuclei will collide with each other and be bombarded by neutrons, which would then convert them into different elements. Interestingly, many of the heavy elements in our universe are formed in this way. Well, there you have it. This is what would happen if our Sun hit another star. Are you surprised? Did you find it interesting? If you did, leave a thumbs up and comment below.
The universe is jam-packed with weird, mind-bending celestial bodies that often test the outer limits of our understanding of theoretical physics. Throughout history, every now and then, a few cosmic flies in the ointment have turned up, leaving physicists scratching their heads saying, yeah, this is how it should work, but yeah, it's anyone's guess really. One of those particular cosmic weirdos in question is the infamous neutron star, the strange wilderness era for any lucky solar sun in their celestial life cycle of the universe, where after being really big, they suddenly get really small and really dense, and physics just has to leave them be and let them do their thing. But what if our Sun suddenly and out of nowhere became a neutron star? Well, let's find out. Hello internet, what's going on, and once again welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your disembodied floating voice Jack Finch, as today we curiously ask the question, what if our Sun was a neutron star? Right then, so neutron stars, what are they and what's the big deal? Well, in short, neutron stars are the collapsed cores of massive suns, but they have a few very particular parameters that they need to meet before they can call themselves neutron. Our Sun, Sol, is pretty middle of the pack when it comes to the weirdness of far-flung celestial bodies, but stars with a much larger mass than our sun burn out after just a few million years in a massive galaxy-rocking explosion known as a supernova. During a supernova, all of the inner cosmic mush of the star in question, millions of tons of plasma and neutrinos, get ejected out from its core at the speed of light. But strangely enough, sometimes there's something left behind, and that little guy is a neutron star. Now, it's important to note that our sun will never become a neutron star because it doesn't meet those very specific set of parameters and conditions needed for it to turn into one. Neutron stars are born from suns that are 10 to 20 times the size of Sol, and in around 5 billion years, the life cycle of our sun will lead it to become a red giant and then eventually a cold white dwarf, which is vaguely similar to a neutron star without the weirdness, just much larger and far less dense. But we don't want that, do we? Because this is a hypothetical life's biggest question, and we want to know what this would mean for our sun and how damn dangerous things would get very, very quickly. What? You didn't expect a happy ending, did you? Well, it's no kept secret that a neutron star is one of the strangest things in our universe. It's right up there with dark energy and white holes, giant flying spaghetti monsters, Cthulhu and all his buddies. Because after spending its life as an absolutely massive star, post-supernova it shrinks down to roughly the size of a small city, around 20 kilometers from head to toe. But you know that stars are spherical, don't you? So don't worry about metaphorical appendages. The thing is though, the fact that these things are absolutely tiny on the scale of the universe, it doesn't account for the fact that a single cubic centimeter of a neutron star weighs roughly 400 million tons. A single cubic centimeter. Now multiply those centimeters by several hundred million and you get, yes, a pretty hefty small boy. In fact, even at that size, thanks to the weirdness of a neutron star's physics, its gravitational force would be roughly 2 billion times stronger than Earth's. That means quicker than a rat up a drain pipe, every single planet in our solar system would be instantly pulled toward the neutron star and destroyed in a hail of cosmic hellfire. Yeah, that's not so good. Also, things wouldn't just end there either, because these little guys rotate at a phenomenal speed outside of our given understanding of galactic orbit. You see, whereas our sun rotates once every 27 days or so, a neutron star would rotate roughly 700 times every second, and it would be hurtling through space at 1/5 the speed of light like a toddler at a Red Bull convention. In fact, if our sun was a neutron star, we'd likely never even know it, as life and everything in the galaxy would swiftly come to an end in the spark of an instant. That's if our sun suddenly morphed into a neutron star, but what if one of those guys came hurtling at us from the deep depths of space without a second thought? Even though a neutron star is roughly only 20 kilometers wide, when compared to our planet, which has a diameter of 13,000 kilometers, you may think that it'd be just like getting hit by an asteroid, but we're also forgetting how heavy these things are. Remember when I said a single cubic centimeter of a neutron star weighed roughly 400 million tons? Well, yeah. If it impacted our Earth, it would be like shooting a bullet through a watermelon. In fact, it's one of the few cosmic entities in the known universe that would literally obliterate our Earth by passing through the core of our planet and exiting out of the other side, 360 no scope and all. Yeah, it's safe to say these guys are pretty deadly, and under any theoretical scenario, things would be really, really bad if our sun ever became a neutron star. But is there any upside to our sun ever being a neutron star? Hypothetically, of course. Well, perhaps, but we'd have to change the mechanics of our solar system for that to even be an option. You see, because despite all of the cosmic calamity that these little guys can cause, it is still often theorized that neutron stars across the universe may have planets in orbit, albeit in a very precarious balance, stuck between a rock and a hard place, so to speak. You see, because neutron stars have such an overwhelming magnetic force, life on such a planet could harness that power similar to how we harness visible light from Sol. Of course, for the most part, a neutron star would emit enough light energy, but the overwhelming radiation from its magnetic force could have completely shaped its course and evolution of any sentient life. An entirely new concept of life could have grown on this hypothetical planet that hangs in the delicate balance of a neutron star's orbit. Sentient life that fed on radiated cosmic energy to become an entirely different life form than that of humanity, using galactic cosmic rays to sustain themselves and perhaps become an even more efficient ancient extraterrestrial life. Heck, if this radiated alien species became an advanced enough civilization, they could even perhaps construct a Dyson sphere, a hypothetical megastructure that completely encompasses the star and efficiently harnesses its energy. There's one thing for certain: whichever way you spin it, a neutron star has more potential energy than any known cosmic entity in our galaxy. If a civilization was lucky enough to grow in the strange, delicate balance of having a neutron star as a sun and survive its cosmic calamity and all the things that come with having one of the most earth-shattering entities in the known universe as a neighbor, then there's also a very good chance that their civilization would be incredibly advanced thanks to the potential technological abundance of a neutron star. Hey, if that's the case, maybe they'll be paying us a visit sometime soon. Oh, I hope they're nice.
The sun. Oh, how I love the sun. I could revel in the sun all day, every day. But have you ever heard of the term too much of a good thing? Because when it comes to the sun, you can absolutely have too much. And if you do, it's not pretty. Hello and welcome back to Life's Biggest Questions, the channel that looks to answer all manner of queries, bright and beautiful, or questions big and small. I'm your host Rebecca Felgate, and today I'm asking, what if the sun never sets? Before we get into this video, I want to hear from you. Are you a daytime person or a nighttime person? Are you summer or are you winter? Let a gal know. Also, while you're down there in the comment section, why don't you leave a thumbs up on this video and share it with a friend? Okay, the sun. Our glorious star that keeps us alive and kicking on Earth. The thing is though, we kind of have the whole light, dark, sun, night, warm, cold thing figured out. It's a careful balance and it works for us. The Earth rotates on its axis, spinning at nearly 1,000 miles per hour at its equator. It completes its revolve every 24 hours, allowing for day and night in different parts of the globe as they turn away or greet the sun. Our life on planet Earth is unequivocally tied to this movement. The ebb is as important as the flow, but what if it was all sunshine all the time? It sounds great, right? And maybe it would be for a few weeks. We would all be loving it. Initially, our moods would likely be lifted from all of the increased sunshine. Social media would be exploding with images of us basking all day long, and bask we would. Although I imagine there would be an increase in sun lotion sales as we need more SPF to keep those harmful rays away from burning us. But what happens when all of the sun lotion runs out? Can we keep up with the demand? Really? That's actually kind of the least of our worries. After the high of the first few days, we humans, we creatures of habit, would start to get pretty stressed. Much sunlight would mess with our sleep patterns, which would mean cranky people, sleep-deprived people, tired people make mistakes, and accidents would start to happen. There would be a rush on blackout blinds to help us get through the night. But even if we could sleep in the dark with blinds, psychologically, we'd be kinda sent insane by it never actually being dark outside. What would happen to nighttime activities? Isn't it kinda seedy to get that drunk in the day? Would we toss out light bulbs forever? Are we gonna retire fireworks? What would happen to cozy nights in, snuggled up watching a movie or drinking a hearty Merlot by the fire? The bougie high-gee dream is dead, and it's sun all of the way forever. Spare a thought for the animals of the world though. They can't buy blackout blinds, they can't simulate darkness, and they don't have opposable thumbs for eye masks. Poor blighters would be stuck in perpetual light, and animal life would start to react really badly. Many would simply die from the upheaval. I guess long story short though, we all die anyway. Hip hip hurrah. Without nighttime to help cool the land, global temperatures would rise to over 100 degrees Celsius, which eventually would mean that the lakes would evaporate, with drought making food production nigh on impossible. We'd barely have enough water to drink for ourselves, let alone give it to livestock. Fun fact for you, but did you know that to produce 1 pound of beef, you need 1,799 gallons of water? We'll be tired, we'll be hungry, we'll be thirsty, we'll be hot, and there will be no beef. Oddly, there would also be floods. With the sun always beating down on polar ice caps, honeys would be melting. The problem is though, they'd melt into the ocean, and we don't yet have enough power to convert ocean water into drinking water. So while our drinking water supply would diminish, our non-drinkable water would increase. For a bit anyway. Eventually, the sun would start to evaporate the ocean too, which would be devastating for marine life. So, hold on a minute. Wait though. We live on a globe. A spinny globe. You know what doesn't spin? Our mate the moon, which means it has a dark side. If the sun was always shining, if the sun never set, it must mean that there would be a dark side of the Earth. Part of the Earth always in darkness. Well, Maybe not always, as I'm assuming we'd still orbit the sun. The issue, though, would then be that the sun would never set for 6 months, and then never rise for another 6. But if this was the case, it would mean that the Earth had stopped spinning on its axis, which would be a huge problem. Again, long story short, we would all keep spinning at the moment that the Earth stopped, which would mean that people, buildings, trees, cars, animals would all be launched into an unsurvivable spin. The Earth's rotation controls gravity, which we would lose too. So, fun, happy, floaty, smashy, either in brilliant sunshine or total darkness, depending on where you were. I actually did a whole video about what would happen if the Earth stopped spinning, so I'll leave a link for that in the description box if you want to know more about that particular aspect of the drama. So, if the sun never set, well, the implications of that would be pretty catastrophic, not least for the lack of UV light discos. Disco, really, Rebecca? You show your age. But okay, let's get a bit more conceptual here. Back in the day, they used to say that the sun never set on the British Empire because their global colonization was so awful and expansive that there was perpetually part of their territory always in sunshine. But fast forward a couple of hundred years and we realize that actually colonization is a pretty terrible idea and that chasing a land of endless sun is a bad idea on a socio-political level too. One last thought, there are parts of the world that actually do enjoy perpetual sunshine, for a few months of a year anyway. Now this includes North Norway, North Alaska, and basically places north of the Arctic Circle and south of the Antarctic Circle. Why is this? Axial tilt, that's why. But the offset is that there are months in the winter where the sun doesn't rise, and then once again we're back to the ebb and flow. It really is part of nature, and it is best not to be messed with. If it was, we might find we don't like the results.
Hey guys, welcome to Life's Biggest Questions. I'll be your host, Jared Bronstein, and today we'll be answering the question, what if the sun was blue? Let me know what you think would happen in the comments down below, and of course, make sure to subscribe and click the bell to be notified of our newest videos. As many of you know, and some of you probably don't know, the sun is referred to as a yellow dwarf, and as hot as it is, it's not nearly as hot as it would be if it were blue. I know that may be crazy to hear. The sun is literally so hot, if anyone or anything got too close, and by too close, we're not even talking that close, they would deteriorate from being burned so badly. But believe it or not, the sun is actually one of the cooler stars out there. Depending on a star's color, you can make a rough estimate as to how hot it may be. The coolest stars are light orange red or pale yellow orange, whereas the hottest stars are blue or a deep blue white. However, color can also determine a star's age and distance. Usually blue stars are younger and much closer in distance, so with that in mind, it's safe to say if our sun was blue, well, it would simply be due to the fact that not only is it a young star, but it's also closer to Earth and much hotter. Aside from the fact that Earth's temperature would be much warmer due to the proximity of the sun in relation to the Earth, the sun's actual temperature would also be much hotter. This of course is not ideal for us on Earth. As we know, we're already battling climate change. The Earth is already getting hot at alarming rates. If our sun was blue, based on science, that would mean it's closer and a lot hotter. Unfortunately, that doesn't end well for us, or really anyone or anything on Earth. If the sun were to go up in temperature and come closer in proximity, and we're talking maybe 100 million miles closer, well, everything would easily be burnt to a crisp. There really would be no way for us to possibly survive with the sun coming down on the Earth so hot. But just to say everything would burn isn't very fun. So let's see what would actually happen step by step. Firstly, yes, we die a horrible death of being burnt alive. It would be painful and quite awful, actually. The entire Earth would actually burn down, from your house to all the trees, cars, highways, quite literally everything. The oceans would boil to a point that they would actually just turn into steam or a moisture of sorts, and the Earth's crust would certainly also break down, exposing the middle of the Earth as well. Of course, none of this is really beneficial for anyone or anything living on planet Earth, but I think it's quite clear we all die. But how would the sun affect other planets if it were blue? Aside from the insane rise in temperature a blue star emits, they are also much larger. Blue stars all have masses that are at least 3 times that of the sun, if not greater. And to give you an idea of how big the sun really is, you could fit approximately 1.3 million planet Earths inside of the sun. So imagine that times 3, at least. And it would be way hotter. Now that we understand Earth is out of the way, and would probably turn to dust altogether, what other planets could be affected and how? Well, ultimately it would change our entire solar system and universe. Aside from losing an entire planet and Earth, which would throw off the solar system as we know it, there are also a handful of other planets that would certainly be affected by this. Mercury and Venus, being closer to the sun than Earth, would certainly be completely destroyed by our new, bigger, hotter sun. Mars would also have its fate sealed due to the fact that, the sun just got way bigger than it was before. But those are the terrestrial planets. The planets that are rocky on the surface. How would the sun growing in size and temperature affect the Jovian planets, like Jupiter, Saturn, Uranus, and Neptune? Well, if science gives us any indication, gas plus heat doesn't usually end up with anything less of an explosion. Truthfully, I'm no scientist, so I can't say for sure what would happen, but based on science, I think it's safe to say all 4 of the previously mentioned planets would most certainly explode. Who knows what other planets unknown to us are also in our universe, but if the sun were to grow to the point that it's considered a blue star, well, it would pretty much destroy most of the planets or asteroids and whatever else is in space within a certain proximity. This would completely change our universe as we know it. The explosions could possibly birth another planet. At this point, it's a lot of speculation because I can't say for sure what would happen after the blue sun destroyed all the planets and most of what's in space as we know it. What I can say for sure is that every planet in the solar system would definitely be destroyed, with some of the planets literally exploding. But who knows? Maybe that's how our solar system came to be in the first place. Maybe the sun being a blue star was the Big Bang that started everything as we know it, and that's how we ended up where we currently are. Either way, it shouldn't be much of a concern because our sun is way past the point of ever being a blue star. But the sun being blue? Well, that actually has happened before. It seems when there are tons of fires happening or a volcano is spewing out dust, it can turn the sun blue. This happens because the dust from the volcano or fires spread across the atmosphere and filters out the red rays coming from the sun. This leads the sun to appear more blue than normal, but that's based on our perception of what's in the atmosphere. In reality, the sun is still its normal old white, or so it appears to us at least.